So this panel is going to look at what the opportunity that RISC-V has across Europe as a source of innovation to really drive the next era, to catalyse the organisations together, to use RISC-V as a catalyst for innovation. So I will get the panel to introduce themselves. There's a real mix of experiences. I think there's quite a few of us who have been in the industry for a while, so I think you'll get some interesting commentary on it. But also looking at how we enable startups and scale-ups to really maximise so that we strengthen the European community and the enterprises available. So I will start with Russell. Would you like to introduce yourself, please?
I shall indeed. So I'm Russell Haggart. I've been to these events before with a different hat on, but my hat I'm wearing today is with a ChipStart organisation. So ChipStart is a UK-based organisation which is rolling out across the EU later this year. So it comes from the Valley. Silicon Catalyst started 10 years ago as an incubator for seed stage companies, not processor companies specifically, but semiconductor companies, really trying to fix the generational divide that had happened with sort of 10 years, 15 years of not many startups happening in the Valley, let alone in Europe. That came to the UK 4 years ago. ChipStart is a pre-seed incubator for chip startups of all sorts, not just chip, it could be EDA or technologies linked to that. We're just starting our third cohort in the UK, and we're looking to launch that as an EU program in Q4 this year, if things come together. So my perspective for this is we're looking at a whole bunch of startups. We're constantly looking, every time we have a call for projects, we don't know until we get applications whether we're going to have enough to fill another cohort. We'd like to have enough confidence that there's an ecosystem creating, continually generating lots more startups. Of the companies on the cohort, some of them don't have anything to do with processors at all. There might be photonics, there might be a tool chain or something, but quite a large number of them have been using processors as a means to an end, so their innovation might not be in the processor end, but they need to put a processor on there. And others are diving right into the guts of a processor and doing something, and we need people that know about building processors, and we need access to cores that will work commercially. So there's a whole bunch of stuff we're after.
Thank you.
Okay, in my case, my name is Miquel Moretó, and I'm an associate professor at UPC, University in Barcelona, and I'm doing my research in the Barcelona Supercomputing Center, so my main focus is on computer architecture and HPC. And basically my role at BSc is to coordinate the different chips that we are designing for HPC in Europe and locally in Barcelona.
Hello. I'm Yunin. I think most of the guys in RISC-V community knows me. I make the first RISC-V laptops, and then now I make just released the first World 50 TOPS AI PC running on RISC-V. And basically, I'm making those modular laptops motherboards to promote the whole RISC-V ecosystems. And we have a big plan coming on this year, end of year, 16 cores, and even next year with 4 and 2 nanometers board coming out once the chip is ready. So hopefully we see some momentum in the whole RISC-V high performance, and especially in AI, and to reach a larger scale of applications and significant software ecosystems to improve, to be improved. Thank you.
Thank you.
Hi, I'm Roger Espada. I'm the CEO at Semidynamics. Semidynamics, we sell RISC-V IP. We have a CPU, we have a vector unit, a tensor unit, and we sell all of it together for AI. Fundamentally, we created an entity that makes it easy for our customers to take into their silicon and have an AI NPU, if you want to call it that way, or an AI engine that will solve the problems that we've been hearing this afternoon of all the people that are doing that. Thank you for having me on the panel.
Thank you, Roger. And I'm Trina Watt. I've been in the industry for about 30 years now. I pretty much worked on every CPU and GPU architecture that's been known, as well as software organisations. Last 10 years, I spent a lot of time working with startups and scale-ups and looking at the critical pieces that need to be in place to make them successful. So I think we've got an interesting panel today. First off, I want to start off, where do we see the current state? Because we're doing this in Europe, we're going to focus very much on the European situation. So I'm interested to hear where you think we currently sit in Europe when it comes to innovation and how RISC-V can help. I'll start with you, Russell.
There's innovation using RISC-V, and there's innovation inside RISC-V, and Europe's got talent in both, Europe's been designing processors for as long as the guys in the States, almost as long as the guys in the States have. So it's decades worth of experience. And part of the challenge, I think, is to make sure that we have generational flow of information, so the next generation know that the comment that was made earlier on about learning about computer architecture rather than just the more abstract part of computer science. So we need to feed that through. But we have a lot of talent, we have a lot of ideas, we have a lot of scope to just take RISC-V, as I was saying before, and just use it, but also to get involved. And a vast amount of the innovation inside the RISC-V activity is coming from this side of the Atlantic.
So it's how we take that innovation and take it forward. Mikhail, you've got an interesting perspective coming from academia. How do you think the current situation is in Europe with academia and how we can build on that from an innovation point of view?
So I would say that in academia we are here as it has been said, we are very good at training talent. So we have lots of undergrads doing bachelor, and in the last years most of the universities in Europe have transitioned to RISC-V, so all bachelor students finish the degree with knowing about RISC-V and being able to develop things around RISC-V. I think this is really good, and we can be happy with that. Also, at master level, we have been adapting. More recently, new masters have appeared, more focused on semiconductors design and trying to do chips, because chip design is complex and it requires time and it requires a lot of specialization for students. So you cannot do it in the first year of the degree, but once you have more experience, this is something that can be done and that is being done in Europe. And when I go to other universities in Europe that are participating in European projects, most of them are doing test chips to demonstrate technology that they are developing. So I think this is really good. Then in terms of innovation, I agree that we are doing a lot of innovation, not only around RISC-V, but RISC-V recently has been identified as the European ISA. And this means that all the funding agencies are opening calls around RISC-V. And there is a lot of innovation around projects because there is funding, there is talent, there are students, so good ideas are appearing. I would say that we have more challenges when we have to transfer these ideas, these good things that we are developing to companies, and maybe Europe is not as good as the US or even China in doing these things. And I think there is something we have to improve. There are representatives of companies here. I think something that is easy that could be done is to try to promote more summer internships for students. And this is something that in the US is working very well, and in Europe is not so usual. Students start a PhD and they stay many times 5 years in the program, and this is something that maybe it's easy to do.
What is your opinion on it? You've got quite a unique perspective coming from Asia and Europe. You've seen the two. So where do you see Europe currently just now?
Obviously, I moved back from Asia back to Europe last year, and then in the last year, early this year, and then I find it now we still got a very big potential in Europe. I'll give you a few examples. First thing is we can do a lot because we have a big market here. At least 1/3 of the market, consumer market here. So there's no doubt that we are one of the most rich market here. So and it would pretty much the same as China in terms of the average selling per person. So and there's and I would see there's a few example. For example, I give you example is a Fairphone. It's a startup making phones, trying to compete with Samsung and any other places. And they make modular phones. They make very environmental phones. You can upgrade, you can fix bugs. There's a lot of potential. And around this area, especially very in Europe, is heavily regulated. But we can, along this regulation, we can do a lot of invention around it. For example, free trade production line and modularized consumer electronics and very environmental materials. And the most important thing is we do something that Far East can do or American can do, and cope with the whole around the speciality around our European stuff. For example, I'll give you an example. Another startup doing a multiple language translation on YouTube videos, and we have in Europe 40 languages. So right. So for example, now we speak English. Actually, if somebody the staff can do, you can translate it to whatever the local dialect on their earpiece. It's a lot of potential in this in Europe, and also and after I go around the European country like Munich, I met a few crazy guys. They just do a modular open source watch, and you can change the CPU as you like, And we have a lot of universities, EPFL, ETH, doing the low power chips. And all we had to do just like venture capital, you just need to connect the dots and find the founder, get the startup going, and then very innovative. And people say it's heavily regulated, then they destroy the startup. But there's a lot of things we can do it a completely different way. Right? You just need to connect the dots. Right? Now our DeepComputing, we make modularized laptops. You don't need to throw away the laptop anymore for the rest of your life. You can throw away the motherboard, and later on we can just throw away the CPU. You don't have to throw away a lot of things. Right? And also, when you become modularized, you can share across different product lines. From a desktop, a laptop, tablet, they all sharing the same motherboard. And you will have the scale of economy. And the most important thing is we're very environmental continents. Right? That's the way I say.
Thank you. Very interesting. Roger? Oh, you've got it.
Yeah, and I got one. I would say that echoing a little bit the demand side in Europe is not strong enough. So if there's a customer sitting in the seats and during the last session in the panel, then what we need is demand, number one, so that the products that we're creating in Europe have actual demand. And also the other thing I would say, in Europe we lack capital, right? And we have a representative here of a VC firm, VC incubator. Capital is really missing. All these things are super expensive. Silicon is very expensive, and it's slow. We come to these summits every year, and we'd like that things go faster. And the reality of life is things go slow, and customers take their time. They evaluate options. They think about what to do. So it is going to take time. It's inevitable that everything will be RISC-V, but it does take time, and until this time happens, we need both capital on one side and demand on the other. So I think in Europe we're lacking both. There's not a strong demand, and there's a definitely weaker capital supply than in the United States.
So we've got the opportunity with the kind of knowledge in the communities within Europe, but that's some of the hurdles. And that's probably the next thing, it's a good segue into the next bit of what are the key challenges that we see. How do we turn these opportunities into a reality, into commercial successes as well, and the innovation that's going to come with that. So Russell, I know you spend a lot of time looking at how we enable these. So what are the challenges do you see that are stopping these opportunities from being fully realised?
Well, I think Roger's nailed it straight away. We talk about money. I should emphasise Silicon Catalyst and Chipstart is not a money-providing organisation, so happened to be a former VC 20 years ago. So my biggest problem is that back when I was doing venture 20 years back, all early stage venture was doing hard tech. And we now have a Europe-wide whole venture community which has been spent 10 years looking for different ways to deliver pizza online and business models and investment models that go with that. And those investment models simply do not translate into investing in silicon at all. And then you've got different sorts of silicon. You might be able to fund a new sensor development with a few $1 million, sub $10 million, and they might be able to do an MPW and go to commercial revenue on that. But you're not going to do that for a processor design. So I think one of the challenges you've then got is there are different sorts of processors. There are processor cores that can go into an SoC and for consumer type applications, automotive, into different verticals, or there are raw processors, the sort of things you want to beef up and put into a data center. My experience in recent times and looking at what we've tried to help the companies on the Chip Start program in the UK and increasingly across Europe, I don't really see at the moment that European venture capital has configured, it's not dimensioned in a way that allows you to develop a sort of a server class processor from start to finish. You might be able to start it and at the right point pivot over stateside where there's more capital, but there are big challenges there. I mean, half the presentations today are talking about AI, which is great because despite the fact that NVIDIA still dominates the market, there is a lot of venture capital still chasing other AI silicon solutions. So if you've got an AI angle, that's worth doing. If you've got half an AI angle, I would suggest you stress that and emphasize that in your pitch, because it will help you. General purpose compute has plenty of scope for innovation, and you've just got to find your product market fit very carefully before you go out and raise money, because the days of venture capitalists betting on a market rather than waiting for you to demonstrate you've already got customers, that's a different category entirely. I would say I think there's a difference of view perhaps about whether you need your customers to be local. I would argue that if your technology is strong enough, then the global market is there to be taken. There are fewer barriers these days to selling your product around the world in terms of not having to jump in a plane all the time. There are other barriers that we know about cropping up as well. If you're developing a world-class and industry-leading solution, I don't think you need to expect that your customers will be local. They don't need to be.
So do you think from investors, is there a different level of risk acceptability in Europe compared to, say, the States?
I wouldn't say it's completely perfect in the States either. My experience fundraising has, there was one UK-based VC who had ARM as one of their LPs, and the company I was working with to raise funds had ARM wanting to invest in a round, and that VC wouldn't open its checkbook despite the fact ARM was investing themselves, and it's very difficult. But then talking to US VCs as a European company, if you're not mature enough to be able to physically be on their side of the Atlantic, then they probably won't look at you. And the ones that would talk to us wanted an AI angle. So I don't think it's perfect over there.
Got you. Miguel, how do you feel the challenges manifest themselves in academia? You said there's lots of opportunity. What are the challenges in the work that's going on in academia moving over into a more commercial position?
So what I can tell you is that in the last years, I mean, we have seen a significant increase in funding, public funding for academic projects, and this is really good for us, of course. But it's basically due to the CHIPS Act at European level and also at national level. It's very good for us because we have the opportunity to do new things, but also the expectations from the funding agencies are really high. So they expect that we will create new companies, like Semidynamics is a very good example, and other companies that will grow, that they will go to market. And this is not easy. I mean, as Roger said, chip design is slow. It requires a lot of time. It requires a lot of investment. And, for example, it's a minor thing, but current European projects are normally 3 years long. So developing a new architecture, implementing it, fabricating a chip, doing the bring up, in 3 years, it's nearly impossible. And then you need multi-year projects that can go one after the other, and then try to do in 2 phases, like we are doing in some European projects. And then this alleviates these challenges. But the expectations right now are very high, and we need to show some commercial success in the near future, so that the public funding agencies, they keep funding
They'll
us.
keep funding it, yes.
Okay, as a start myself, and I will see that in Europe, it definitely have problem with raising fund. I don't think it's a matter of not enough money in Europe. It's just that they channel it through, not through to the startup and all the high tech. It's probably a lot of conventional family office, whatever. It's rich enough. I give you experience, right? My last startup in Hong Kong. My US dollar fund, all the LPs, European family office, right? They do the due diligence check on the fund, and then I was the startup. They invested, and they say, why? How do you see this fund? I say it's great. Investing Hong Kong startup with attacking Chinese market and then helping have a global vision. I would say it's still rich, but it's just the culture of it. And to be looking growing market, they're really hard to look into the saturated market, even it's really close to them. And the other thing is that, right, and one of the reasons why we're doing startup, we had to endure the difficulties, go around the difficulties, right? At the end of the day, right, raising funds does not borrow money. You can't sleep well, right? All we had to do is earn the money from the market, and we are happy, right? Market is just the moment of time that you just now I would say, and you just need to put out market fit, whether you fit it. In look at our DeepComputing, we set up the roadmap is 1,000 pieces, 100,000 pieces laptop, the 100,000. So I'm going to see it through in 15 years because we just done 15 years, right? You had to have the plan to go through the difficulty through the 15 years, in which you see the 100,000s, off you go. You have the scale of economy. If 100,000 people here using RISC-V consumer electronic, you shout it at Google to fix the browser, you shout it at Apple, you have to connect my RISC-V device, they will fix it, right? But it's going to be very difficult, right? You take a look, I've done 4 generations laptop already. Look at the RISC-V community. Our cell is a producer. We are not, our cell is a consumer. We don't consume RISC-V stuff. So if you want to blame ourselves. Even myself in my startup, I invest a few startups, it's still difficult to use RISC-V laptop to produce things to sell into the market. It's just the way it is. It takes time, right? But we had to see this as difficulty and as an opportunity. And you have to walk around the difficulty and see it as an opportunity. Because no one else is going to do it.
No, and you keep persevering and persevering too. It's not going to happen overnight. And I think that's what's coming out in all this, the challenges. It's not an overnight element. Roger, what's your thoughts on these challenges?
Which one of them?
Pick your favourite.
No, one of the customers. No, I can only echo what he's saying. I mean, how many people in the room have a RISC-V laptop? I don't, and I'm guilty, right? So that's number one. Demand creates the money channel or funnel that ends up in the end enticing the investors to invest, right? So step 0 is how do we create that demand, and it's not just here; it's China and U.S., right? I don't think it's a European thing, but definitely, given the geopolitical situation, we could do certain things. But again, people want a fast laptop and they don't want to wait for Windows to boot, right? So it's 2 changes, right? It's moving them to, I'll call it Android, Linux, doesn't matter, something that's not Windows, that's a change. And because they don't care if it's RISC-V, we care, but they don't care, right? So yeah, there's an idea, a challenge where can we get Europe to say, hey, I'm going to buy laptops for security reasons from Europe. Problem 2, Well, the ones he's doing have come from a CPU from China. So if you're taking the geopolitical angle, that's not going to work either, right? So we need to do more work. And to close, going on the other side, he said there's a lot of money, and it is true there's a lot of money, but depending on where you are in the supply chain, the amount of money until the things you're doing reach the consumer and the market explodes is different, right? It's not the same if you're the laptop guy, if you're the board guy, that you're the silicon guy, or you're the foundry guy, right? It's even worse than if you're a foundry, right? But so it does take a lot of time, and we do, at the risk of boring people, the capital in Europe is, echoing your words, is definitely not in the mindset or has the timelines or understands the timelines of what are the returns I will get, what are the risks, and therefore what is my probability of investing. It's off the things they're used to. So the VCs in Europe, that doesn't mean you cannot go get a VC in the US, but then the first question you get is like, oh, can you move the company? So, and that's fine, you can move the company. So it's a decision you have to make. But if you ask from a European perspective, the things we need to fix, this is a very long investment pipeline, so you have to start putting gasoline on the left to get fire on the right? So it's a very, very long engine.
Mm-hmm. Yeah, and it's not an overnight thing, it's those linked elements. So are there things that we can learn? We've talked about the challenges, to try and address these challenges from either other regions or particular market areas that have been successful that we should be looking at as an example of how to overcome some of these challenges?
I think I've got two areas to talk about. So, number one, funding is not necessarily a write-off, only because 20 years ago, Europe did a really good job of doing this. We need to find a way of doing it again. So back 20 years ago, 30 years ago, early stage venture capital was very happy to invest in all sorts of hard tech, very happy to invest in silicon. And by the way, that happened totally organically. There was no government strategic program to make that happen. There was genuine opportunity and money flowed in. So something needs to happen, but we've done it before, so maybe we can do it again. One of the challenges is, it's been already mentioned, is the cost of entry. If you're a startup, how do you get going? Is the talent all in one place? Can you have engineers working online? I'm personally a great big fan of being able to swivel around in my chair and talk to someone without setting up a Zoom call, and don't quite think the tech has replaced that yet. So you are probably looking at geographic centres of where the engineers can come together to do that. We have plenty of those clusters around Europe. There are cost of design tools, and some parts of the supply chain have got quite good competition and ability to engage with startups. Others perhaps less so. So one of the things that we do at Silicon Catalyst is to allow that initial adoption at the early stage, and individual supply chain companies have had their own offers as well, so we're not unique in that. So there are things we can do to help companies get out of the starting blocks, and we can make sure that those remain appropriate and that they evolve. Not every startup needs to be aiming to do a 2-nanometer tape out. There's plenty of innovation at the lower cost end of the range as well. So I think to some extent what I'm really trying to preach is hope. It's not all doom and gloom, yeah?
We've done it before in the past, so surely we can do it again.
But there's already stuff happening as well now in that direction. There's motivations and want to make this happen. So it will not be easy. Then designing a chip takes a while as well. So maybe we just have to look at the company formation bit taking a while too.
Okay, in my case, I think that if we want to do just a European chip that is specialized for a given niche market or whatever, I think this is going to be very complex to achieve, basically because all the companies and institutions in the US and China are doing the same. I think Europe should try to take advantage of the openness of the RISC-V ecosystem, try to leverage what is being done in other places, and try to take advantage of that. And this is especially important, I would say, for the software ecosystem. And this is something Europe has been contributing a lot to the open source software ecosystem, and now with RISC-V we have an opportunity to keep pushing this. And for hardware, I would say that recently there was the Open Hardware Foundation that was moved to Europe. And this is something that is also a good opportunity for us to try to have open designs that everyone in the world can use, everyone in the world can contribute to, but it's based in Europe and it is being promoted by the European institutions. That's something I would like to happen.
Yeah, Trina, you're asking how we're going to over all these difficulties, right? I would say that, right, compared to well-established big company, startup, the only thing we get is strength and flexibility and speed. If we do a startup, haven't got any of those, and then you need to think about you better back off, right? You can't compete with a big company. You're same as a big company, right, with less resources. And the other thing, because we have a flexibility, you have less money, right? Just now at the summit, we kick off the whole blockchain crypto currency with outsource AI, hardware IP, and all these things. We need to proactive looking for the money from other places, from the mountain, from the valley, from the sky, from bloody Mars, like Elon, right? So, and we have all the flexibility. And all we have to do is go and find it. Go and find it yourself as a founder. And don't expect people come in and grab you because we are nobody, right? Even though we are very somebody in RISC-V, right? The other thing is about the demand. I think in RISC-V, the whole ecosystem, whenever back in Hong Kong and in China, I do a speech, the whole RISC-V industry, the resource we have got, I don't think even can compare half of the ARM company internally. Don't even mention NVIDIA or AMD. Or Qualcomm. I don't even mention any of those. And what we can do is different way. I think this morning we have a 15 years birthday. I think the union has to get stronger. The demand, we have to get it sorted out ourselves first. Right? We had to create the demand of the 3,000 RISC-V members. Come on, create the demand yourself first. Right? Don't expect people don't care RISC-V to create demand for you. You're asking, just not asking somebody to do something impossible. Right? Like myself, so I make it, I force all my staff start using this year. Right? Slowly. Right? It's painful, but come on, it's my money, right? Go and use it. Right? I produce shit, you have to stay with the shit until the shit becomes better, right? And we have 3,000 companies, 3,000 members. It's a strong amount, right? For a startup to cope with. By the time I sell 1,000 pieces, I have a confidence to do with 10,000 pieces. And then I can put order to you. I can give all the problem. For the MPU is no good, toolchain is no good. I say use Semidynamics. Come on, straightforward. He proved again. I can force them to do use because I put 100,000 orders. Right? By the time I have 10,000 orders, those people can bet. If you give 100 orders, no one can bet. Right? So as a conclusion, Yulin, you become Yulin RISC-V. You're Yulin. You sorted out our own problem before we blame someone else. That's all I say.
Yeah, your question was, can we learn from others? And the answer is absolutely yes. I mean, to spice up the afternoon, if you stay far away, the U.S. and China are not that different despite their differences, right? Meaning the U.S. has for many, many years stimulated their technology economy through purchases, through military, DARPA, many, many programs, not centralizing what was happening. They do it in a certain way. China is not that different. China said, I want autonomous computing, go do it. And in fact, it's interesting because if you look at China, they bet in everything. They did PowerPC, ARM, RISC-V, Intel, MIPS. So, you know, each province gets one, and in the end, the central government says MIPS wins or RISC-V wins. Okay, we're all doing RISC-V. That's the way they do it in China. Not that different in the US, although they'll be really offended in the room. But what I mean is that in Europe, we are fragmented, and we don't have that power of purchase. So third time I talk, third time I say demand, right? If the governments are fragmented, there's no central authority that can say, okay, all the school laptops are now going to be with this technology. It doesn't even have to be RISC-V. It should say with a CPU built by a company that's fully European, right? RISC-V is a little delta on top of your question. So the learning, absolutely. Let's copy the Americans, let's copy the Chinese. They're not that different. And let's do the same. We just have a very complicated political system in Europe that makes it far more difficult to achieve the levels of purchase power that those two governments actually have.
Yeah, so it's a simplified kind of decision process from that side of things. So just to kind of close off, so if there's anyone sitting in the audience who is building innovation on top of RISC-V, either as a startup or want to do a startup or a scale-up, what would be your piece of advice you would give them for innovating on top of RISC-V to give them the best chance of success? It's a good, tricky one.
Not sure I did any advance notice of that question. Well, the obvious one would be to get as much. I think what you're hearing from the panel is we're not really talking about the technicalities of RISC-V at all. We're talking about the practicalities of building a company, navigating an ecosystem, and so on. So, although the innovation bit has to be engineer-led, the company has to be commercially led. So, I mean, that's a fairly straightforward thing to say. There are incubators around, not just ours, but there are other ones which are around Europe. Some offer more value to hard tech startups than others. So find one that suits. Take as much advice as you can. If it's your first time, it may not be your first time, but if it is, grab as much input as you can. Find your market fit. I think fundamentally, that'd be my view. You've got to. Yes, it's great to if you believe in your product, use it. I totally get that, but if your company's only got 50 people, that's 50 users. That's great for debugging it. It's not going to create a market. We've got big chip companies in Europe using other processor technologies. Yeah, so we've got ST using selling vast numbers of ARM cores. So we can't necessarily expect government to do us favours and start buying RISC-V. It has to sell it on its own merits. So it'd be great if there was strategic coherency, but you can't bank on that happening. So the product has got to be able to stand on its own 2 feet commercially.
Well, in my case, I have little experience with startups because I never created a company. But I would say I would agree that identifying the market that you want to target and focus there and make sure that what you are going to offer is a really good product. I think this is what I would recommend. In my case, I have colleagues that have tried to do chip design for some specific markets, but these markets were so small that after a lot of effort, they realized that it was basically impossible to make a profit out of it, even though the technological proposal was really good and it was a clear advantage.
Yeah, it's not that kind of like you've got to get a critical mass that you can go after. And I think it's also being able to explain your innovation to your market. I've seen a lot of technologies fail. They've been technically fantastic, but they couldn't get the benefit across to the market enough that people would either invest in it or buy it. So that is another critical piece in that, is making sure you can communicate your innovation out into the world.
Yeah, I agree. First of all, when you look at the market side, never trying to raise funds to get anything to successful. Yeah, at the end of the day, the market will say that you're successful or fail. Right? You can't leave it on capital for the rest of your life. And regarding RISC-V, all the time my analogy is to Linux kernel. Imagine 40 years ago when Linux comes out, it's bloody difficult. It's bloody 100 times difficult than we are now. So I agree with Russell saying that hope. And at the end of the day, right? All we experience with x86, but we are not really deep involved with. But RISC-V, we can deeply involve it, and we can make it happen. So as I run a few startups, I always say to all the young people, the only thing you can make an influence is on RISC-V. First thing is part of the human civilization. It's openness. The reason why we have war, because the people is not open enough to trade, to compromise, to exchange. RISC-V is open. And the second thing is that, and we share. And we had to maintain that philosophy. And I'm sure if Linux kernels are successful now, dominate Android, dominate server side, and soon dominate the AI side, I'm sure the openness for RISC-V comes. It's going to be very difficult because we need to sit the wave, the mass market waves along the change of the earth, into the geopolitical, the decentralized, the localism, the racism, the nationalistic, all these things. We navigate through. And I would still persuade whoever interested in doing startup, do something with RISC-V. We're going to make it. It's going to be difficult, but it's worthwhile. If we can do the most difficult things, the easiest startup, other thing is easy. Thank you.
We didn't succeed in having any disagreement because we're all echoing. I'm just going to repeat, but I'll say the same thing with different words. My learning is RISC-V is an enabler, right? So with ARM, you cannot change ARM or x86. RISC-V says, do whatever you want. This is an enabler, right? That's not sufficient. The next step is solve your customer problem, right? That's, for me, has been my learning at Semidynamics is, oh, I have this cool instruction. That's first year PhD attitude, right? Oh, you got to buy because I added an instruction. Okay, grow up, right? So growing up is about, okay, what is the customer problem and solve it. So I do think RISC-V is fantastic because it enables you to create a solution for somebody's problem. And at that point, that someone is say, oh, I would pay money for that because I had a problem and you are solving it for me. So I think that's the beauty of sounding slightly contradictory. Innovation per innovation is quite pointless. It's okay in a research environment. There's many environments, but when it gets to go to the market, you have to solve a problem. And innovation helps you solve the problem, but don't go to your customer just telling you, oh, buy it because it's new. No, buy it because I solve your problems. And I think RISC-V allows us in many different markets to solve those problems that the other ISAs are not capable of solving. And so I think that's why it's going to win, right? That's the reason.
Yeah, it's the flexibility that it can enable those problems to be solved in a different way. Yeah, perfect. So I think we've got time for a couple of questions, if anyone has any questions for a member of the panel.
We got them all asleep.
If not, we can finish.
All right, since there was I'm over here. All right, since there were no disagreements, I'm going to try to light some fire and everybody's asleep, so let's wake them up.
Yeah, wake them up, please.
So let me ask a controversial question and try to be as honest as you can. Is there a culture problem in Europe? Are we too rich to do this stuff, and is it too late to start now?
No, I don't think it is. I mean, we have the talent. When there is an established legal system, an established set of boundaries between countries, an established power balance between the governments and the EU and the regions and the mayors and whatnot, it's difficult, very difficult to change it. And yes, when you're rich, there's no revolution, so the change will be slow, right? So I don't think there's a cultural problem. I don't think the Europeans somehow are less productive or less capable of creating the technology, but I do see the government side being slowed down by the many divisions we've created over centuries, right? So that would be my take.
Well, two questions were, is there a cultural problem and is it because that we're too rich? Yes and no, I would say. I'm coming at a different direction from Roger. Yeah, I've been pitching UK-based processor design teams to US companies in all sorts of ways, and I think European engineers think that all this cool stuff, the really successful stuff, happens on the other side of the Atlantic. So I think the cultural problem is that we don't believe we can do it as well as those guys can, and there's absolutely no reason why we can't. We have done it historically, and we can do it again. There are some big names on the other side of the Atlantic, but that just means they've got good PR agents, as far as I'm concerned. We have really, really good engineering talent over here, and we can do it, and we just need to convince ourselves. So that's the cultural problem I see.
It's an element of belief, and I think it's going back to how the industry was maybe 30 years ago, where it was very centralised. In Europe, there was a lot of innovation coming out of Europe, so it's a belief. I think it's a belief in ourselves of what is capable, because I think the innovation that you see in Europe is a completely different way of approaching those problems, and I think if we can tally that up with RISC-V and that flexibility, but believe, and get a good PR agent.
Yeah, I totally agree. I think it's just belief is one thing, and as some the other side of my role is as an investor, we look at it whether the trend is on your side. You bet on your trend, right? Open RISC-V is definitely a trend. You're going to be 1/3 of the ISA market. It's no doubt. It's a matter of time, right? I give you an example. If we want to make RISC-V successful, very easy. Right? Going to convince the NVIDIA switch to RISC-V. You straight away, right? Go to convince Huawei to switch to RISC-V. 95 minutes, RISC-V will be successful. You're going to convince Apple as well. Very simple, right? But why they don't do it and leave it to all our staff of the hustle? We're doing it because they have different agendas. They are big, just like governments. Right? So we as Europe, I'm sure we can do it. As I say, we have done ARM, right? It's from Manchester University, right? We have done Nokia, right? I used to run Nokia as a mobile phone, the feature phone. We have everybody think myself. I don't even look at the other side of the Atlantic, right? We can do it. If it's Skype, all of this destroy, right? So we have everything, we have all the talent. You can see, take a look, EPFL, a few guys, do a 16 nanometer low power chips, spending $250,000 only, right? We have all the ingredients here. It's just someone, probably like, need someone probably, Russell can convince, connecting all the dots. We're going to make it. Right. Whether there's a one like that in China, they have a CPP. They add in the one. All the head of the province, you have to compete. You're not allowed to follow. You have to compete. Who lose out? This is a creative market, free market, creative free market. You call control free market, whatever it is, right? But in Europe, I'm sure we can do the same, right? Right, in Germany, you find someone, you're Switzerland, going to compete with them on the robotics, right? On the bio, whatever. We still can do it. I'm pretty sure we will find a way to stimulate. We walk along all this culture, walk along this belief, and we can be a level playing field against all other continents.
Okay, I think we have some cultural problems. I would say at least in Spain and some other countries in Europe, for many years, the basic research in academia was seen as something that was not intended to be productive, like being transferred to the market. And in fact, a national supercomputing center like BSc, where I work, it was illegal to transfer technology to companies because we were a public institution and our technology was from the state. And it is pretty recent, I think less than 10 years ago, that we were allowed to start creating spin-offs. And this has changed a lot the kind of research that we are doing. So now every year we are creating 2 or 3 companies at least. And we see more and more people trying to transfer technology to companies. But this requires a lot of time. And I think the US and also China is far ahead of us. So we have to catch up. and let's see if we can do better in the next decades, I would say.
And I think we have an onus on ourselves if we see those hurdles, question them, push on them. You know, if there are barriers that you see coming up, as you say, doing academic work that could never move into commercial work, that is, we should be questioning those barriers. So I think from culturally, question. Why are we doing it this way now? Does this work? So I think having that question and pushing, if we don't push, those barriers won't come down. Cool. Any other questions? Or we can close the panel and you can go and get a drink.
I'm here.
Where's it?
Up here.
Sorry.
Oh, yeah.
Yeah. Hello. Listening to the panel, I was basically thinking, and I raised like two questions in my mind. And one of the things is, if you're looking about consumer technology, which is something like, you know, we're looking about laptops, and you're thinking about, oh, why we don't have RISC-V laptops, and why do we don't have any other kind of consumer products that based on RISC-V? And do you think that this is an issue of like a lack of knowledge of people about anything related to European technology? Because if we think about it, you know, we don't use any, let's say, we are using a lot of European technology in our products, but we don't know about it. So if you look at, for example, a smartphone, there's a lot of European technology, especially in security, embedded in every smartphone, but people don't know about it. You mentioned a manufacturer, and they never heard of them. I mean, I'm talking about general population, you know, unless we are in this kind of ecosystem here. So in order to kind of promote, you know, the use of our own technology in some of these, let's say, consumer computing products, don't you think that there's a little bit of education about, you know, what we are actually doing here, and that we should actually think about it before we are just buying whatever is off the shelf? That's, you know, my question.
Oh, you talk about consumer electronics. I think we enter into a very monopoly market, right? And you see mobile phone. You can't get away from Android. You can't get away from Apple, right? And then you're using a mobile phone with a communication. You can't get away from Qualcomm. Right? So we use, I think, all these supply chain of all the consumer electronics. We definitely, there's a lot of European technologies. But if we approach this market using the same way as the big company does it, we're bound to fail. Right? So they are all heavily integrated. They heavily mass-produced. They heavily streamlined, right? So because they have a scale economy, right? But if like me, you ask doing with framework, we're doing a completely different way. They heavily integrated. We heavily modularized. We bet on it. We take the other side of the world. Right? I'm sure we have like 5 billion of people. We just need 5 million people to bet on us. We win. Right? That's how we see this consumer electronics. So exactly the same as a Fairphone. Right? Fairphone just backing on it. I just backing on the environmental. Right? Now they get a deal from all the train company because it's so environmental, so durable, and same as Nokia before. Right? We just need a different, but it's different field or different scale of a competition only. You will find your niche market. And as your company, you run the startup or run a sustainable business, it's going to work. You find a way. You control your book, right? You find your market, you earn a big customer, you spend a little bit more R&D, right? So I would not think that it's difficult to create. Now the problem with consumer electronics is just the RISC-V does not live up to the expectation yet. Soon. Give us another 1 or 2 years. We can touch people's bottom, and we're going to hit it really hard. Right. That's my point on the consumer electronics.
Thank you. I've been given the time up signal. So I'd just like to say thank you very much to our panellists today for having an interesting and an insightful view on what is going on with RISC-V and innovation. And thank you very much for sticking with us to the end of the day.